Hello and welcome to another LeetCode video. Today we're looking at LeetCode 3606 coupon code validator. It's an easy problem and we're going to approach it interview style. So we're not looking for the fastest way to implement this or anything. Instead, we're going through the motions that we go through during an interview where we explain our approach, show a systematic way of solving the problem, do runtime space analysis and all of these good things before we write any code. And yeah, let's just get into it. So step one, what are we dealing with? Well, so we are given three arrays of length n that describe the properties of n coupons. And a coupon consists of a code, a business line, and an active flag. And the code is a string that represents the code identifier. The business line is a string denoting the business category of the coupon. And is active is a Boolean flag indicating whether the coupon is currently active or not. Now, a coupon is considered valid if all of the following conditions hold. The first condition is the code is not empty and consists only of alphanumeric characters, so A to Z, upper and lowercase, including 0 to 9, and underscores. The second criterion is that business line is one of the following four categories: electronics, groceries, pharmacy, or restaurant. And the third and final condition is that is active flag is set to true for that coupon. Now we should return an array of the codes that are all the codes of valid coupons sorted first by their business line in the order electronics, grocery, pharmacy, and restaurant, and then by their code in lexicographical ascending order within each category. Right, so in an interview, I would now ask, what should the output exactly look like? What can we expect of the input? Are all of these three arrays always going to be the same length? Can they be empty? Is it possible that I'll be giving a none reference or nil reference? All of those things in LeetCode, it's typically included in the problem description or down here in the constraints. And you can see that all three arrays have the same length. We're giving less than 100 codes, which for our runtime and space and complexity analysis, we're just going to ignore this because otherwise everything is automatically going to be O of one time and O of one space. However, we're going to take this information that there's at least one entry in each of the arrays. No, actually I'm wrong. What was n? Here it says the length of the arrays could be 0, but what is n? Oh, that is the entry of the elements in the array. So if there's an entry in the arrays, it is not empty. That's what that says. My mistake. Now, code I and business line I consist of printable ASCII characters. So it could really be any ASCII characters. Interesting. However, so that is probably why we need to check, whether the codes are alphanumeric with underscores, because they could contain other characters as well. And finally, is active is either true or false. Okay, great. So now I think the problem is quite clear what we need to do, but in an interview, you should always ask for an example or make up some examples on your own to understand the problem a little bit better and to make sure that you didn't overlook any edge cases that you currently don't see. This happens more often than not, and it happens predominantly when the problems get a little bit more difficult. So with an easy problem, it's the probability that we missed anything by not looking at examples yet is relatively low. But since we're going through the motions of the process, we're going to look at the examples. Example 1. So we have input codes save 20, farm 20, save at 20. So that would be an invalid code because it's not an underscore, not alphanumeric. All the other two codes would be valid. Then we have the business lines. All of them should be valid because they are included in our list. And is active is all true. So I guess here we should return these two codes, farmer 5 and save 20. And that is because we are sorting them. So sorting by the category, that's going to be something we need to pay attention to. Let's actually see. We have electronics, grocery, pharmacy, and restaurant. We should return the code sorted by the business line first. So this would be E, G, E, and R. So I think they already are in lexicographically sorted order, which is nice, so that we can just use regular sorting. We don't have to do any custom sorting for this. So, but that also explains, how we're going to reverse the order of save 20 and farm 20. That is simply because G becomes before R. Groceries becomes for restaurants in lexicographical order. So, okay. Then finally, the second example, we see these codes are all valid. Invalid is something that's not valid. So that means the third code gets eliminated. And the first one gets eliminated as well because the flag is false. So the only one left is electronics_50, and that's what we return. Okay. All right. So I think we've spent enough time now looking at the problem, and let's think about an approach now. So I believe that we can just do a linear pass over all of these elements in the 3 arrays. That will be O of n time. However, we also need to check whether the codes are valid. And since we can't just use a normal, is alphanumeric in Python, we also have to check whether underscores. We probably need a little helper function to implement, to check whether code is valid. And so that runtime will be the length of the codes. So I'm thinking we'll have O of n times m time. But we will also have to do some sorting in the end. I'm just writing it down. So n is length of code. M is max length of any code. And well, if we do the sorting with a sorting algorithm, that would be of n log n. However, since we only have 4 categories, we could also use something like a bucket sort or counting sort to bring down the runtime to linear time. So I think we would have this time complexity, and in terms of space, well, we obviously also have to store everything. And so we'll come up with the same storage requirement as the input has. In the worst case, when everything is valid, we'll have to store all of the codes, and each code can have a certain length. So I think that would be my runtime and space complexity analysis, and we have the option of how we implement the sorting at the end. So at this point, I would ask the interviewer, are you fine with me implementing this? And then I says, of course, yes, this sounds awesome. And yeah, well, then I would just start implementing it. So and I'll do exactly what I just proposed I would do. So I'd probably have a result array. And we need to return it at the very end, right? So now I said I wanted to iterate over all of these 3 arrays at once. And in Python, you can do that quite easily with I would rename code to codes so that I can use the variable here. So for code, business line or category, and the active flag. And then I'll just use the Python zip function that gives me back an iterator so that I can iterate over all of these 3 arrays in parallel. And since they all have the same length, that's not going to be a problem. Okay, so now I have to perform all my checks, right? So if is valid code, and I need to implement that method in a bit. And I'll just pass in the code here. By the way, I'm leaving out the type annotations. For production code, I would of course include them, but in an interview, I would ask the interviewer if it's okay if I just omit them. And then we'll say yes. And this is purely so that I can save some time. I mean, the reason why I chose Python in the first place instead of Java is to save time typing, so that I can focus on the logic and not the syntax. So, and we'll have to perform some checks here, and I'll implement this in a little bit. But for now, let's just assume we have this method. So it has to be a valid code. Well, then we have to check, well, is it actually, is it active, right? If active, we also have to check, if it's a valid category, right? And, well, we can check whether it's a category that is inside electronics, grocery, pharmacy, and restaurant, right? That means it's a valid result, and we can include that into our result, but it's not yet going to be sorted, right? So, well, how should we do that? Well, one thing we can do is we could just append it, and we could just append the code and the category. So that could be one thing, and then in the end we're going to sort, and then we're going to remove the category. Maybe we should, yeah, let's leave that for the moment. And then what we'd have to do here is sort by category, remove category, and remove the category again. And then we can return the result. But before we do that, let's simplify our code a little bit. So, well, we could combine these two if statements, right? It makes it a little bit easier to read, I suppose. And we should implement our isValid method because that's going to be a central part of it. So if not code, return false. Now, if we get a code, right? If it's an empty string, that's not going to be valid code. Then we need to iterate over all of the characters. And code.lower. So I'm lowercasing it so that I can use the if the is alphanumeric. There's a function in Python for that, and that only works when it's a lowercase. Right? When you pass in, I think it was that way. When you pass in uppercase A, when C is uppercase A, then as alphanumeric will return false, if I'm not mistaken. Could be wrong, but I think that's what's true. Well, if it's alphanumeric, that's fine. We're going to skip over it. The second check is if it's an underscore. That is also fine. However, if it's anything else, we need to return false because then it's not a valid code anymore. So that is our O of M time operation. That's where the M comes from in our runtime analysis. Right. So now we filtered out all the valid codes in the right categories that are active, but now we need to do the sorting. So I'm thinking about how should we do the sorting? Well, one thing we could do is we could build, like I said before, we could simply do, well, we could sort the result array first on the category, first on the code and then on the category to get the prime result. But I would like to implement a different approach. And I would like to use a hash map for this. Where we just collect the valid codes in every category. Actually, let me think about it. So maybe this is an option of how we could do that. Because I'm thinking we probably won't get away with linear time sorting after all. I think that was a mistake that I did earlier because we don't know the order of the codes and we need to order by the codes as well. Right? So we will have to correct our runtime analysis because we have to use a sort function. We cannot use like a bucket sort. So that's actually, well, worst case it's n log n time for sorting. The worst case is when all codes are valids, they're all different, etc. So yeah, I think with that being out of the window, I guess the easiest way to do the sorting is to use the built-in sort function, and then we might as well sort the result array like so. Return result.sort, and then we're going to sort on all of the elements in it. So first by code. Yeah, and first we sort by the code, right? And then we sort by the category. Right, what did it say? Return an array of the codes of all valid coupons sorted by first by the business line in order and then by the code. And the way to achieve that is encode first order by the code and then by the category. Because sorting is stable, meaning that the order of elements is not going to be changed when they're sorted on a different criterion. So first we put all the codes in the correct order lexicographically, and then rearrange them by category, but all codes in the same category remain in their order that they were sorted on when we call sort for the first time. We could also do it simply like this, but keeping the key in here makes it maybe a little bit more clear. So now the last step is just to remove the category from our result array. And we could do that in place maybe. Let's do it like so we don't have to build a new array. And then we just say result at position I is going to be result at position I, and position 0, that is going to be the code. So we're replacing the arrays of that we put into the result array with just the code. Right, so this is going to be the log n time, and of one space, by the way, then sorting is done in place in Python. And this one is going to be O of n time, but also O of one space, so it doesn't change our overall runtime complexity at all. And this one is O of n. Cool. So we could simplify this expression if you wanted to. You can. Or you could just leave it. Both are correct. Neither's wrong. One's just more detailed than the other. So now let's see whether we made any mistakes implementing and whether there's any syntax errors. And there are. We're missing a colon here. If the character is an underscore, then we skip over it. Okay. Try again. And we're passing our 2 test cases from the problem description. Let's now submit it to see if we pass all of the tests. And we do. Happy times. And yeah, so that concludes that problem. So you can see, even though this was an easy problem, it's actually, well, it's quite nice to use it to practice for interviews because, well, you're forced to talk through it, you're forced to reason about your code, but the difficulty of your problem is not getting into the way of practicing this process. And that is really the main point why you should do easy problems, so that the process becomes second nature to you.